All right. So, basically the quiz is just like everything about polar as it like shows at the top of the review. And I'm just gonna go over like a brief intro to like polar stuff so you guys understand it more. So the polar, okay, basically like you have this graph, right? It's the same as like your X and Y graph. But in terms of like polar things, like when you're dealing with X's and Y's, you're actually dealing with R's and thetas when it comes to polar. And you're still plotting them like the same way. So like I don't want to give like an example. Well, maybe I should. So let's say that here, let me go through my pictures and see if I can give like a really quick example of like what it means to like switch between the two because they're essentially like the same graph. Like the X's and the Y's and the R's and the thetas, they're the same graph. You can interchange between the two. You just have to go through some conversions. So let's say that you had a polar coordinate. Let me make one up. Let's say that you had 2 comma pi over 3. And you know that this is polar because you know the theta value is usually like an angle. So it's the pi usually. So this is like an indicator that it's polar and not regular rectangular. We know that r is equal to 2 and theta is equal to pi over 3. Now let's like kind of like graph this on the like the actual graph that I drew over here. I'll do it in red first. So pi over 3, if you guys remember, it goes like pi over 6, pi over 4, pi over 3, and an r of like 2, let's say that you have like a radius, it would be like over here, right? So that's where it's located on the polar graph. But where would it be located on the x and y graph? You have to convert. And that's where like it's important to introduce like the conversion formulas. So, and I don't think you're gonna have to use too much of this one, but they are important. So, important formulas. We know that x is always going to be equal to r cosine of theta, and you should 100% write these down. Like you need to have them like ingrained. Y is equal to r sine of theta. We have tangent of theta equal to y over x. And then finally, r squared is equal to x squared plus y squared. Now, these formulas, like, they're just extremely important because they're going to kind of be like your way in to like switching between the two and also dealing with other problems relating to it. So I highly recommend that you learn them. But for this particular problem, and it's not the one that's number one, there's just like a background of polar and rectangular information. We're just trying to switch between what we have over here to X and Y like format. So let's see. We know R and we know theta. And we know these two formulas for X and Y. So what I'm gonna do is erase what's on the top because it's kind of jumbled up and then convert. So let's figure out what X is. X is equal to R cosine of theta. We know that R is equal to 2 cosine of theta. Theta is pi over 3. 2 times cosine of pi over 3. That should be 1/2. And then we get that our x is equal to 1, right? So we already know this part over here. Now the y. Let me just erase these two on the bottom just because we don't need them for this particular problem. And you're mostly going to be working with these two over here. So focus on those. Y is equal to r sine of theta. The r is 2, the sine of pi over 3. And then you're going to end up with radical 3 over 2. And then we get that the y is equal to radical 3. And then like when you end up plotting this, let's say that this is like 1, 2, 3, a regular rectangular graph. Notice how it kind of lands at the same spot. You know, the x is 1, so we know it's going to be somewhere here. And then if we're going to be if we're trying to try to be precise, like this would end up landing somewhere here and it would end up being the exact same spot. So I guess like the moral of this like kind of lesson or prelude is that It's essentially the same thing we've been working with since forever. You just need to kind of think in terms of like the unit circle, like when you're doing it in your head. Does that kind of make sense as like an intro?
Yeah, that makes sense.
Okay. Yeah, just let me know if you need me to stop for a second. Um, I do want to help, so just let me know, okay? All right. Let me just clear the screen, of course, and then start. Let me just make the pen a little bit thinner. Okay. So first, find the polar points of horizontal tangency. Okay, so now I'm gonna give like our first big important formula for this lesson. The ones that I wrote at the top are before that x is equal to r cosine of theta, and then the y is equal to r sine of theta. Those are like your background formulas, but this is like the first big formula. Um, Horizontal tangency. Remember, tangency is slope, so it's derivative. How do we find the derivative of like a polar equation type situation? Well, it's the same as before. It's dy over dx, right? But there's more. For this particular problem or for polar equations, you need to consider dy over d theta over dx over d theta in order to figure out what dy over dx is. And then once you put this value on top of this value, you get the tangent point or your dy over dx or your derivative. Does that make sense so far?
Yeah.
Yes.
Okay, and the reason why this formula works is because let's say that we were going to do keep, change, flip, whatever. We flip it, d theta over dx, cancel, cancel. It's the same thing. So that's, I guess, like the root of this formula, but that's not important. So find the points, the polar points of horizontal tangency. Well, if you guys remember, like from AB, whenever a point has a horizontal tangent line, like let's say that the point is this, and the tangent line is what I'm going to be drawing in red, it's a slope of 0. It's just horizontal. When it's vertical, obviously it's a vertical line. That's when you have a 0 in the denominator and it's undefined because it's just a vertical line and that's the way it goes. But horizontal tangency means that the slope is 0. So if we're looking in terms of this, important formula, we need to figure out when the numerator is going to be equal to 0, because that is when your entire slope is going to be equal to 0. If it was asking for a vertical tangency point, which is actually number 2, but I'm only going to do number 1 because I just want to do one of each type. You would set denominator equal to 0 because that's going to be when it's vertical. Remember, vertical means undefined. Undefined is when you have a 0 in the denominator. Really important. But for this particular problem, we're just going to be looking at the numerator. So I'm going to find dy over d theta and then set that equal to 0. And then that's going to be where we continue with this problem. And it's not too bad, actually. So let's figure out what dy over d theta is. Well, in order to figure out what dy over d theta is, I feel like we would need to know what y is, right? Because you need to figure out what y is before you take the derivative of it. And we know y is this formula at the top. So let's just plug in what we know. We know that r is equal to 6 plus 3 sine of theta, and we have the formula. So y is equal to, I'm going to plug in r, so 6 plus 3 sine of theta, and then sine of theta. Don't forget this part over here. And we already know what our y is. Now we need to take the derivative of this like little expression, which is just normal derivative. So I'm gonna use like I'm not gonna like distribute it. I'm just gonna end up using like the product rule. So remember, it's, I don't know if you remember it, but you go the derivative of this one times this plus the just this times the derivative of that. So let me just do it. So the derivative of this term over here is 3 cosine of theta. You keep what's over here, so sine of theta, plus you keep what's on the left, so 6 plus 3 sine of theta, and then the derivative of this term, which is cosine of theta. Is that formula like familiar to you guys? Like, do you remember
Yeah,
doing
I
stuff
do.
like that? Okay, okay. Um, and then all we're gonna do is just make this equal to 0. But let me just kind of like make this a little bit prettier. So this is really 3 sine of theta cosine of theta, and then you have a 6 cosine of theta because I just distributed that. And then when I distribute it to this one, you have a 3 sine of theta cosine of theta. And we're going to figure out when this long term is equal to 0. Um, for when you're dealing with like sines and cosines and really anything with like x's or variables, you want to avoid like canceling things out. And you're gonna like Miss Q always tells us to factor instead, and then see what you can do from there. Oh, sorry, I meant to erase this. So let me just erase everything at the top and show you guys what I mean.
Joseph,
Yes.
tell me again what you did to cancel out the cosine squared theta.
What do you mean by that?
Never mind. That's a sign. Sorry, sorry.
No, no, no. Yeah, don't worry. Yeah, I don't see a cosine squared. But yeah, let me know if you have a question about like a certain step that I did. But what I mean by factoring is it's just easier to kind of split your sines and your cosines apart, because then it'll be easier to figure out when the value is equal to 0, because I wouldn't be able to tell you when this is equal to 0 just by looking at that. I noticed that every single term in this expression has a cosine. So I'm going to factor it to the beginning. So cosine of theta in the front, and then you're left with 3 sine of theta here from this term. You're left with just 6 over here from this term, and you're left with just another 3 sine of theta from the last term. When you end up simplifying this, you're left with cosine of theta times 6 sine of theta plus 6. And then now, if you guys kind of remember, like from factoring in middle school, in order to figure out the values that work with this expression, all you're going to do is kind of like split it apart. So we're going to do 0 is equal to cosine of theta. And then we're going to try 0 is equal to 6 sine of theta plus 6. And remember, all of this is to figure out when this thing is horizontal. So this is all we're doing. If you know the unit circle, you know that cosine of theta is equal to 0 at pi over 2 and 3 pi over 2. And with some manipulation, you move a -6 here, you have a 6 sine of theta. When you end up simplifying the one on the right that I've been writing in red, this ends up becoming sine of theta is equal to -1, and it's equal to -1 at 3 pi over 2. So note, these are our theta points where it will be equal to 0. It will be a horizontal tangent. And at this point now, I guess you would stop if it was just asking for the theta values, but notice how it's asking for the actual point, the coordinate. And if you go back to that little review I did, remember that the coordinates are in terms of r comma theta. It's not in terms of x and y unless you're dealing with a rectangular problem. It's r comma theta. And it's asking us for the points of these. So we need to find the r comma theta of each of these little points. And we already know the theta of these because we know that theta is equal to pi over 2 and 3 pi over 2. This is a duplicate. So all we're going to do now is just plug it into the original equation to figure out the other point. So let me just erase. The theta values are really the only important things we need to keep. Let me just, sorry, I'll just keep erasing actually, just so I don't get rid of everything on the screen. I think that's enough space for now. So all we're gonna do is plug in pi over 2 and then 3 pi over 2 into this original equation. R is equal to 6 plus 3 sine of theta. When you plug in theta over here, you end up getting 6 plus 3, and sine of pi over 2 is 1. You get 9. And then when you plug in theta to the bottom one, r is equal to 6 plus 3 sine of 3 pi over 2. Sine of 3 pi over 2 is -1. So you end up getting 3. Now that we know our r value for each of these theta values, we can figure out our coordinates. remember the coordinates are r comma theta always. So our first coordinate based on this one is going to be 9 comma pi over 2. And then our second coordinate for this one over here is simply going to be 3 comma 3 pi over 2. And those are the two answers for this problem. So does anyone have any questions, or that made sense?
That makes sense.
Okay. Let me just grab my review just to make sure that I'm doing things correctly. But yes, that is good. All right. So the next problem on the review is very similar to what we just did. Okay, yeah. It's asking for the points of vertical tendency. So just to do a review, because I'm not going to do it, you're going to find when the denominator is equal to 0. So when dx over d theta is equal to 0. Julia, do you have a question? Because I see something in the chat. Yeah, go ahead and ask.
Mic wasn't working. We don't have to graph it though.
No. You don't have to graph it. When we get to the area problems, that's when Miss Q says that we're probably going to have access to a calculator because it's kind of hard to do them without the graph. And I'll kind of show you guys how to do that. But I would say it's really the area ones that require the graphing, like absolutely. The rest, like, you can kind of do without the graph. Yeah, I couldn't hear you. Say that again.
All we do is just write the coordinates at the end and circle them.
Yes, that's it.
Thank you.
You're welcome. Yeah, these are actually like easier points. I will say the area is actually kind of difficult when you think about it. And then maybe I guess like the arc length, because it does require you to like know how to integrate normally. And I know integration is not everyone's favorite, but these are just like regular derivatives, which I know are easier. So it shouldn't be too bad. So definitely aim to get these right on the quiz. I want to do this one last. The tangent of the pole, because it's a very like specific topic. I know how to do it. I don't fully understand why you do it this way, but I know how to do it and I want to show you guys, but it's very like niche. It'll only be like one question. And I'd rather do something where it's going to be like multiple questions. Intersection is just basically finding when these two intersect. You guys know when they intersect, they're equal to each other. So 1 is 3 equal to 6 sine of 3 theta. I don't think that requires too much explanation, but so I'm gonna go on to, let me see, number 5. Number 5 is just another like similar problem where you are like trying to see when it's equal to a certain point. And I guess I'll do it just because just because it's a little bit different. All right, so it's saying that r is equal to 2 cosine of theta. It's telling us that it's from 0 to pi, and it's telling us there are 2 points where r on r where the x coordinate is equal to 1, and it's telling us to find these points. So it's again finding points, the coordinates that we've been doing. Just for a reminder of that, we're basically finding these r comma theta values, and we're trying to figure out when the x coordinate or the rectangular coordinate is equal to 1. Remember, it's very easy to switch between the two because if we go back, we know the formula for x is equal to r times cosine of theta. We already know r, so all we're going to do is plug in r. So we have 2 cosine of theta times cosine of theta. And now we know that this is equal to 2 cosine squared. And it's telling us that this x coordinate is equal to 1. So we're just going to plug in 1, right? And at this point, we know that we're looking for a value when cosine squared of theta is equal to 1/2. I don't usually like taking the square root of things because it usually gets rid of answers. But like, I guess for this particular problem, it would work. So let's just do it this way. When you take the square root of this, you end up getting the square root of 1/2 is equal to cosine of theta. And remember, this can be plus or minus. And with some manipulation, so let's say that if you're, just in case you're confused on how to like simplify this, a radical with a fraction inside, you can rewrite it as the square root of 1 over the square root of 2, in case you didn't know. And this can be rewritten as 1 over the square root of 2, because the square root of 1 is just 1. And then obviously we don't like to keep radicals in the denominator. So we're left with radical 2 over 2. And if you know your unit circle, this is actually a very common point. It occurs at every like pi over 4. Then you have 3 pi over 4. And then you have 5 pi over 4. So whenever you have like the over 4, the pi over 4, that's when it's going to be equal to radical 2 over 2. So, and I don't like how I did this in black. Sorry about that. I'm going to switch colors. But basically, we know that, and let me just erase all this work that I did here, just so that it's a little bit clearer. We're trying to find when this cosine of theta, all this work was just to show that we're just trying to figure out when this cosine of theta is equal to plus or minus radical 2 over 2. And like I said, it's going to be whenever you have like the pi over 4 values. So remember, before I write these values, we're only looking from 0 to pi. So we're only looking from like here to here. We're not looking at the ones over here, because remember, it goes from 0 to pi over 2 to pi, then you have 3 pi over 2. But once you get over here, it's already too big. So we're only looking for values within this little theta range. So when is it equal to that? So I told you guys, it's only when you have like the pi over 4, and that's just from like your unit circle knowledge. So pi over 4, and then you have 3 pi over 4. So these are our two theta values, and all we're gonna do now is figure out the r, because remember, we need the r and the theta to figure out a full coordinate. Let me erase everything here so there's more room to work. Julia or anyone, does this make sense so far?
Yeah, I'm getting it.
Okay, perfect. All right. So all we're gonna do is plug in for each theta value that we found. So let me just write them at the top, because I find that that's easier when you're doing your work. So we're gonna plug in 2 cosine of pi over 4. And then we're gonna plug in 2 cosine of 3 pi over 4. Cosine of pi over 4, we literally just did this, is radical 2 over 2. That's just radical 2. And then 2 cosine of 3 pi over 4, it actually becomes negative. So this is negative radical 2. Julia, is your mic not working? Yeah, I can't hear you.
Because my mic doesn't let me talk when like other people are talking. So
Oh, okay. So what's your question? Sorry.
a little while back, I wanted to ask. I was confused on how you went from radical half to radical 2 over 2, and like
Okay.
understand the rest of
But
it.
you do understand like how cosine of pi over 4 is equal to radical 2 over 2, right?
Yeah.
Like you know that from the unit circle?
Yeah.
Okay. So I'll review that once I finish writing answer to this problem. But the most important thing is that you know that cosine of pi over 4 is equal to radical 2 over 2. That's the most important thing. But basically at this point, we already know our r's. So we know that the first coordinate, I'll do it in green, is radical 2 comma pi over 4. And the second coordinate is negative radical 2 over 3 pi over 4. And those are our two answers for this problem. But I'll do another like review of just like manipulation. And the reason why I did that, just because I guess like in a normal problem, you don't really have to do all that manipulation. But these are the two answers for this problem. But let me just erase everything here so that, let me just clear it. Okay, so Julia, like the reason why, I think I did something wrong. Give me 1 second, because I think I need to share my screen again really quickly. Sorry, iCloud Drive, the review, and I think it was this one over here. Yeah. Okay, so Julia, the reason why, and I'll try to pause so that you can answer questions along the way. I don't know why the audio cuts out like that, but the reason why I like rewrote this so that it would have end up being radical 2 over 2 is because when you look at the unit circles, there's usually a radical in the top and then nothing at the bottom. It's never really written like this. It's always radical at the top, regular integer at the bottom. So that was kind of my goal for this, because when you're trying to figure out when cosine of theta is equal to radical 1/2, I wouldn't be able to tell you that right off the top of my head. But when it ends up looking more like this, then I can kind of familiarize myself with what I know from the unit circle, and then it's easier to come up with the answer. And the reason why, or I'll show you how I manipulated it. So like I said, when you have a fraction inside of a radical, you can rewrite it as radical 1 over radical 2. Same thing as if you have radical 3 over 4. You can do radical 3 over radical 4. And for this problem, this will end up simplifying to radical 3 over 2. Just like this will simplify to 1 over radical 2, because you can just take the square root of what's over here, or the square root of what you already know. And then the reason why I just didn't leave it like this, Julia, was because remember Miss Q and all mathematicians, I guess, for some reason, don't like it when you leave radicals in the denominator. And the way to get rid of them is to just multiply by the same radical. So if it's radical 2 here, you just multiply by radical 2 over radical 2. And this will end up like eliminating your radical. And I keep saying radical, sorry about that. You end up getting radical 2 over 2. And notice how that's the same thing as what we have over here. So does that make sense?
Yeah, thank you.
Okay, yeah, no problem. Right, clear. Let me see the next one. All right, so find the slope of the tangent line. And I want to do this one because it is prevalence. And it's basically what I was showing you guys before. We've been dealing with like slope problems so far. So these are like easier points, I would say. All right. Remember what I said about the slope. It's dy over dx. And just to show what that means in terms of polar problems, you're looking for dy over d theta over dx over d theta. Notice how now it's not asking for a vertical or horizontal, it's asking for the actual slope. So it's actually asking for this. So in this problem, we need to find both. And I'm gonna actually ask you guys to kind of like help me figure it out so that I'm not doing all the work, just so you guys kind of like know how to manipulate. So we need to find y, we need to find x, we need to find dy over d theta, we need to find dx over d theta, we need to put them into this formula, and then we plug in this point, which is really theta is equal to 0, because if you guys remember, it's r comma theta. The 0 is in this place, so it's when theta is equal to 0. But that's more important when we get to the end of this problem. All right, so I'm gonna ask each of you to like help me figure this out, just so I'm not doing it. But I'll start you guys off by writing the two original formulas from all the way at the beginning of the review. X is equal to r cosine of theta, and then y is equal to r sine of theta. So Julia, what do we do first?
Okay, give me 1 second.
Yes. Or how about this? Like, if you need more time to think. Oh wait.
Okay, so you're gonna plug in r into, I want to do y first. So
Okay,
you're
let's do y first. Oh,
y
sorry.
2 minus 2 sine of theta in the parentheses, and then outside of the parentheses, you're gonna write sine of theta again.
Perfect. Next.
Then you're gonna write dy over d theta.
Okay.
You're gonna take the derivative of what's inside the parentheses and write that first.
What is that?
Okay. It's 2 cosine theta.
You're forgetting a sign. Negative 2 cosine theta, right?
Negative
So
2 theta.
okay. And then you leave what's next, right?
The sign on the outside, and then you do plus, and then you write r the way that it is. And then on the outside, you're going to take the derivative of sine of theta, which is just cosine theta.
Yes. So this is your derivative of the top. Um, I would give you guys a tip for this particular problem. Notice how it's asking us to find the coordinate at that particular point. You can simplify this if you really want to, but I kind of find that it's a waste of time because at the end of the day, all you're going to be doing is just plugging in the theta, which is theta is equal to 0, into this over here because we're going to be plugging it in there. So what I did actually is, let me just kind of erase what I have over here. Once I took the derivative, I didn't simplify anything because I didn't want to waste time because you know that this is a time test, you have time constraints, etc. So I just figured out what dy over d theta was, and I plugged it in into my, original formula, this little blue star-ish shape that I did. So it's like Julia said, it's -2 cosine of theta, sine of theta, plus, I'm gonna run out of space, but it's 2 minus 2 sine of theta, cosine of theta. And now all we're missing is the denominator. So let's do that. Natalie, how about you tell me what to do?
For the
If
x.
she's there. Yeah, for the x.
Okay, so you're gonna start off with x is equal to r cosine of theta. So we have to plug in the r.
Yes.
Plug in 2 minus 2 sine of theta in parentheses and then cosine of theta at the end. And then we have to do the derivative for that, dx over d theta. So that's just the power rule again. So you would do the derivative of the first one, which is -2 cosine of theta, right?
Yes.
Cosine of theta times cosine of theta, because you leave, the second one alone, plus 2 minus 2 sine of theta, and then times negative sine of theta. That's the derivative of cosine, right?
Yes. Perfect. And yeah, again, I would just leave that the way it is. I wouldn't, I mean, you can simplify it kind of. I don't like, I kind of skip steps a little bit. So when I move this part over here, to the denominator, I'm just gonna rewrite it as -2 cosine squared of theta, because you have two cosines here, so you can just write that as cosine squared. And then this negative over here, I'm just gonna move it to the front. So it's minus, then the 2 minus 2 sine of theta. There's like no space. Sine of theta. All right. And then what I'll do is I'll tell you guys the next step, and then I'm gonna have Kate just tell me how to simplify it. And it does require unit circle knowledge. So hopefully you kind of know it, Kate. But all right. So basically at this point, we already know what this is, our slope. We already know the tangent line, we know the slope, we know all that. And we know that this long formula is going to give us the answer to that. Like I said, we need to figure out what the slope is at the polar coordinate 2, 0. Like I said, remember it's always in terms of r, theta. If we match it up, we get that theta is equal to 0. And notice how I'm only paying attention to theta is equal to 0 because in this long formula we did, it's all in terms of theta. There are no r's there. We don't need to worry about r. We're just looking at the theta value. So I'm just going to plug in when theta is equal to 0. And the way to notate that, on your work is you write dy over dx. Oh, sorry. You write dy over dx. You draw a line and you're just writing it when theta is equal to 0. So basically what this denotes is that you're plugging in 0 for every time you see a theta. So I'll do the plugging in because that's important. And then Kate, I want you to tell me what that ends up like simplifying to, and we'll go term by term. 2 minus 2 sine of theta is equal to 0. It's a lot of work, but at least it's simplifying. It's not too bad because the zeros are kind of easy to remember. So 2 cosine of theta 0 squared minus 2 sine of 0 sine of 0. All right. So Kate, I just want you to go like term by term. So what is, okay, so let's just leave the -2. But what is cosine of 0?
1. So it would be
And then sine of 0.
0.
Next, what is, okay, so you have 2 minus 2. Sine of 0 is 0, like you said. and then cosine of 0 is 1, like you said. And then what is cosine of 0 squared?
Is it just 1?
Yes.
Yeah.
And then I'm just gonna rewrite what we did at the top. 2 minus 2 times 0, and then another sine of 0. So before I like to do anything, like anytime you see that you're multiplying something by 0, you can kind of just like cross it out. So this one over here and this one over there, because anything you do, it's gonna end up being 0. Now, when you simplify this in the end, we're only left with this one and this one. So it's, and let me just do this in green because it's a little bit easier to see. You have 2 minus 0, right? Because that's 0. So you can kind of cross it out, times 1. And then you're left with negative 2 times 1 in the denominator, which is just negative 2. This is 2 times 1, negative 2. The answer is negative 1. And that's the final answer to this problem, just negative 1. Any questions? Because that was kind of long.
No.
No. Okay. So again, not like slightly long and tedious, but not impossible. So that's like a benefit. The next type, the next type of problem I want to do, I think, is the area. This is very similar. So notice how it's asking you for the slope and it's asking for a specific data. So same type of thing, not too bad. But the next type of problem I want to do is the area. All right. Okay. So the area is, remember, all this time we've been dealing with derivatives, but we have like 3 more big formulas that are very important for you to remember. And the first formula is the area, of course. So let me write that here. So when you're dealing with area, the formula is as such. So you have a is equal to 1/2 the integral from 2 different bounds, and we just write them as alpha and beta, but those are just 2 random variables. The integral of r squared with respect to d theta. So that's kind of what you're looking for. And the hardest part of these types of problems, at least, are to figure out what the bounds are, because it does get a little bit tough. And I'm going to do one problem of area because it is the toughest. And I think that it's easier to figure out the arc length and the surface area revolution, which is the next 2 problems. But if you have more questions about the area, I can show you guys after the review, but I want to do like one of each. All right. And Judah, this is when you're gonna kind of want to start graphing. So if you guys can take out like your graphing calculators, because you guys are gonna need them, and I'll show you guys the commands. Because you do need to switch your calculator into a different mode when we're dealing with polar. Do you guys have them ready, or do you need to grab them?
I have it.
I have mine.
Perfect. All right. So first thing all you guys do is to turn it on, and then click the button mode, and then make sure that if you go down to like the 1, 2, 3, 4, 5th line of mode, it'll be like function, parametric, polar, and then SEQ. Make sure it's on polar. Click it, and then you can just do second quit, and then you're good. So then once you do that, once you click y equals at the top, as you guys would normally graph, everything should now be in terms of r instead of y. Does that show up for you guys?
Yeah.
Okay, so what we're gonna do is just plug in the r for this problem. R is equal to 7 plus 3 cosine of theta. And then just click graph. If you guys don't know how to put theta, there's a button under mode that says like x, comma t, comma theta, comma n. If you just press that button, a theta will show up. So when you put graph, depending on what your window is, because the window determines like what it looks like. If you make your window from 0 to, let me just graph this one more time because my window was messed up from a previous problem. If you graph it, oh, sorry, I shouldn't have done that. If you graph it from 0 to 2 pi, you should get a shape that kind of looks like this. right? I just did a rough sketch. And it's asking us to find the area inside the graph of this function to the left of the y-axis. So the left over here, right? So basically we're looking for only the shaded region that I drew. And I don't know if I've lost you guys, at least with the window part. Did you guys get like an image similar to what I have? Like a little circle,
Yeah.
oval. Okay.
Mine is like
I want
an oval.
yes, an oval. I want you guys to do two things first. So if you click window, okay, so how do I explain this? All right. Sometimes when you draw the graph, it may actually only do half of it. And sometimes when you do the graph, it's kind of like overextending itself. Because notice how it's a circle, polar graphs go like, circular, like back and forth, around the circle over and over again. So it may like kind of draw over itself sometimes, but sometimes it only just does like half of it. So I wanted to like test drawing half of it. So if you click window, and Julia, are you still there? I haven't heard you.
I'm here.
Okay. If you click window, the first two buttons you should see are theta min and theta max. Do you see those two?
Yes.
Yeah.
Okay. It should by default land, I think, at 0 and 6.283. Right? Or no? Okay. Let's leave the 0, but change the 6.283 to just pi. You guys know how to write pi, right?
Yeah.
Second
Okay.
up, right?
Second arrow, like that little arrow thing. When you click graph, notice how the circle is now in half. Or the oval, sorry. That's important to know, like, because there are going to be some shapes and some areas that require you to like test and figure out which theta values are there. Because let's say that this particular problem was actually asking us when, let's say that it was actually asking us to find this part over here. Oh, sorry. I'm so sorry. Wait, let me just redraw this. Let's say that the area was asking us for this little shaded part that I'm making up right now. Notice how that's like an oddly specific region of the graph, and it's actually not asking us to consider this, this, and this. So if you're ever confused on like which area you're looking for, I would just suggest like playing around with the graph and like seeing which picture resembles what you've done on your paper. I highly recommend drawing it on your paper, shading it just so you can get a visual of what you're looking for. But just to give you guys like an estimate of how to kind of manipulate this, by knowing your unit circle, it goes from 0 to pi over 2 to pi to 3 pi over 2. And notice how it looks like it's starting over here and ending over here. So it's just within that first quadrant. If you guys change your window now from 0 to pi over 2, the region that shows up on your graph should kind of resemble what we've kind of isolated in the Zoom screen. Do you guys see that?
Yeah.
Okay, so that's going to be how you guys manipulate. So it's just important, to manipulate with the calculator. Miss Q has always let us use the calculator for these area problems, not to integrate, but to figure out these two values over here. Because if for this particular problem, let me erase some of this, because for this problem, it's actually asking us for, sorry, let me just redraw the little blue oval. Oh, sorry. Gotta switch. Okay. It's actually asking us for the area inside the graph to the left of the y-axis. The y-axis is obviously this, so it's asking for this part over here. I can eyeball it and tell you that it's from pi over 2 to 3 pi over 2, right? But if you were unsure of that and kind of wanted to test it to see, you can just plug in those unit circle key values like 0, pi over 3, pi over 4, etc., and kind of guess to see which one gives you the closest shape. And now we change the window from make your theta min pi over 2 and make your theta max 3 pi over 2. If you do that, the region that pops up should look exactly like what we have. And that is just kind of like your intro to playing around with the calculator to figure out your theta values. There are other ways to simplify it, but it does help you out this way.
Joseph,
Yes.
say that last thing again about min and max and the graph that we have.
For this, in order to figure out, or like in order to get a picture of what we're looking for, your theta min should be the low, like your low point, like the end point, the integral bound that's lowest. So this one over here, so pi over 2, and then your theta max should be the higher one, so this one, so 3 pi over 2.
Thanks.
And for this particular problem, those are the two bounds for this particular problem. So I'm gonna leave the picture here, but at this point we already know like what the formula is. So we know it's 1/2 the integral from pi over 2 to 3 pi over 2 of r squared. And r is this. So it's 7 plus 3 cosine of theta squared d theta. One thing, guys, I don't like to do a lot of work. I like to simplify my life to the best of my ability. And I'm going to tell you what I did to simplify it, and I want you guys to tell me if it makes sense. I rewrote this integral as 2 times 1/2 the integral, and let me just erase this formula because you guys should have written that down. 2 times the integral from pi over 2, pi over 2 to pi of the same r, 3 cosine of theta squared d theta. Basically what I did was, instead of going from here to here, I went from here to here, and then, which is now this little part, and I multiplied it times 2 because these two parts are symmetrical. And I find that I guess it really doesn't matter. Like when you're dealing with any of these points here, it's pretty easy to integrate. But usually I find that these two are easier to work with. So that's just something I did. Not really fully necessary for this problem, but like it does give you like an insight into what you can do to manipulate, because sometimes it's just easier to do the half times 2 versus doing the full thing from those two endpoints. Does that make sense?
Yeah,
Yeah.
I have questions though.
Yes.
My first question is when we draw like the graph, is 0 pi over 2 pi and 3 pi over 2 always going to be the numbers that we're going to put on those ends?
No, because sometimes just because of like the and that these are why, like that's why the area problems are the hardest. Like sometimes it'll actually ask you, let's say that it'll show you another graph like this, it'll ask you for this region over here, and notice how like these points, like these little black points that I'm marking, are not easily identifiable. You can kind of guess and like estimate what they are. Like I know that this is probably like pi over 6, and this is probably like negative pi over 6 or something, but like it's not that simple. It just depends on what your bounds are. And this problem does happen to be easier with the bounds. Um, I don't know if that answers your question, but no, it's not always those like little points. And that's why it's important to kind of like guess and check, but also use like smart guessing, because like you can estimate the location. And it's not going to be some weird one like pi over 5. Notice how we've never done a pi, like what is the like cosine of pi over 5? It's always pi over 6, then pi over 4, then pi over 3, and then continue around the circle. But it's usually going to be those.
And then so then I'm confused as to how we got to those points then.
We got to those points because we actually could eyeball it with this particular problem. We know that it's based on the y-axis, and I've kind of drawn all over the place, but it's based on this y-axis here. We know that little circle's this, and we're looking for this shaded black region here. The y-axis, the only two endpoints that you could have are pi over 2 here, and then when you go to the bottom, it's 3 pi over 2. So that's why we knew for sure it was those.
You use the unit circle to do that.
Yeah.
And
The unit circle is like your best friend.
okay. And the last question I had was that when you go to put it into the formula and you have a over b, how do you decide which one's A and which one's B?
Remember that whenever you're doing an integral, the smallest one is always your low thing. Um, like your small, like your low endpoint, your lowest value is the one you put at the bottom, and then your upper endpoint is usually the bigger number, and that's the one you put at the top. Um, and you just need to know that like pi over 2 is smaller than pi. And if you remember the unit circle, like it does kind of go in increasing order. So 0 is less than pi over 2, but then pi is bigger. And then in the end, 3 pi over 2 is the biggest, so on and so forth. And obviously there's like little values in here that work, but that's like the gist of it. Does that make sense?
Yeah, thank you.
Okay. So obviously I'm gonna integrate now. That's like, I guess the hardest part is setting it up. And if you don't really know how to integrate, I guess integrating itself is also pretty difficult. But these two cancel. So you get rid of the 1/2. I guess that's a bonus. I'm gonna square what's on the inside, and I guess I'll do it on the side just so you guys can see it a little bit better. Um Actually, is that a 7? Yeah, I wrote it as a 2. Sorry about that. That is a 7. 7 plus 3 cosine of theta. You can do this in your head, but like in case it's easier for you to do it on the side, it's FOIL, so it's 49. Actually, wait, I'm not gonna draw the arrows. It's 49, and then you have 21 cosine of theta, and then you have another 21 cosine of theta, and then you end up having a 9 cosine squared of theta. And your final thing of this, which is not necessary, like you can probably do this in your head, but in case it's easier for you to do it this way, you end up getting this. And this is what we need to integrate right over here. 49 plus 42 cosine of theta plus 9 cosine of cosine squared of theta with respect to d theta. And this is, guys, like where it does get a little bit tedious with like the integration, the simplification, this and that. And this is also where I want to introduce two very important identities that you guys are going to be using 24/7 with this particular unit. So we've used these identities before, but the two that we're going to be looking for, or using specifically, sorry, are cosine of squared up. Sorry, let me just write this more at the bottom actually. Cosine squared of theta is equal to 1 plus cosine of 2 theta over 2, and sine squared of theta is equal to 1 minus cosine of 2 theta over 2. These are two important identities. Write them down, highlight them, do something to memorize them, because you guys are going to be using these a lot. The reason why we have to is because, yeah, it's easy to integrate this. Remember, you just add a theta here. What's the integral of cosine of theta? It's sine, so 42 sine of theta. But what's the integral of cosine squared of theta? There's no formula for that. So it's easier to make this part over here into something we know how to work with, which is a regular cosine without the squared. And that's why we kind of replace it. So at this point, before I integrate, I'm going to replace, sorry, pi. I'm going to replace, and I'm going to rewrite all these terms that we still haven't really dealt with yet. But I'm going to replace the 9, I'm going to replace the cosine squared of theta with this identity here. So this is 1 plus cosine of 2 theta over 2 d theta. Yeah. With further simplification, and I don't want to like completely go into it because it is more algebraic, but so I don't want to waste your time with that. But you do end up getting in the inside before we finally integrate, you get 107 over 2 plus 42 cosine of theta plus 9 over 2 cosine of 2 theta. That you get from like simplifying this to the max. I don't want to fully simplify that now because I don't want to waste too much time, but that is what you end up getting. And I guess if you're following along, the important thing is just the integration. The simplification you can take your time with, and you can do on your own, like some like terms. Like it depends on how many steps you want to show, but this is also correct because if you can do it in your head, do it. But when we integrate this, you go term by term and you integrate. So 107 over 2 just ends up becoming 107 over 2 theta. We're dealing with theta, so don't write x, write theta. Like I said, the integral of cosine is sine, so you end up getting 42 sine of theta, right? And then the integral of 9 over 2 cosine of 2 theta. This is the one I like to do on the side. So you have 9 over 2 cosine of 2 theta, right? When you're dealing with like a number on the inside, remember that you need to have the derivative on the inside in order for you to integrate it. So we're missing a 2 here because it's 2 theta, we need 2 d theta. But when we add a 2, we have to do a 1/2 on the outside. So the integral of this ends up becoming 9 over 4 sine of 2 theta, which is the answer to that particular part. So 9 over 4 sine of 2 theta. Don't forget the bounds. It's from pi over 2 to pi. So when I erase this, now all we're going to do is just plug it in. And then I guess we're almost done with this long problem. And all the area problems are pretty much this long. So sorry. So remember to do the bounds. You plug in the upper bound first. So 107 over 2. This is pi plus 42 sine of pi plus 9 over 4 sine of 2 pi minus the lower bound now. So 107 over 2 pi over 2. This is 42 sine of pi over 2. And then this ends up becoming 9 over 4 sine pi over 2. Sorry about that. Okay, so now at this point, I would just cancel out the ones will end up being 0. Sine of pi is 0, so this is not important. Sine of 2 pi is 0, not important. And sine of pi over 2 again is 0, not important. I know it's kind of tedious and long. Sorry about that. All right. So let me start from the top again, keep working my way down, and then I promise we're like almost done with this area problem. And then the other two are not as long, I would say. They don't require as much integration like steps. So at this point, all we're left with, because we've replaced some of these terms with 0 just to simplify our lives, of course, we're left with a 107 pi over 2, right? And then I'm gonna just cross this out because we've already dealt with this. Minus, inside the brackets, we have 107 pi over 4. This is this term over here. We're not looking at this. All we have left is a plus 42 sine of pi over 2, which is really 42 times 1, because sine of pi over 2 is 1. We have 107 pi over 2 minus, now let's go term by term, 107 pi over 4 minus 42. Sorry about this. There's so much work with this problem. And then now, all we're left with, I'll change the color again. We can rewrite this as 214 pi over 4 minus 107 pi over 4, because we won't have the same common denominator, minus 42. Then you finally end up getting 107 pi over 4 minus 42, and that is your answer. That is the final answer, or the most simplified version of your answer. That one was kind of tough. I'm sorry, but did it kind of make sense at least? Anyone?
I kind of got lost in the middle, but I think I figured it out. Like I know I understand what it was that I got lost on.
So I would say it's like the integration that kind of like messed it up, right?
Yeah, that's where I got a little mixed up, but I kind of found my way back.
Not
Yeah, it's just like the simplifying everything. It's like once you get to like the busy work after the integration.
okay. The areas are the hardest ones. So like if you have to sacrifice like time to not do them, I hate to say this, but like do the other ones first and then do the areas for last because those are the hardest ones. Those are going to require you to know formulas, formulas within formulas, long, tedious works of integration. There's like a lot of room to mess up. But luckily, the next one is pretty easy. And those are the surface, I'm sorry, the arc length one. So these are all area. These are more practice for you. But this is arc length. So this is a new formula. Julia had to go. Like, I don't want to do this like without her because this one is like really important. Yeah, like I don't want to like do an arc length one and her not to get it because I do like I want you guys to get as many points tomorrow as possible. Yeah, sorry. So I guess I'll start off by saying what the arc length formula is. So we just did area, now we're doing arc length. The formula for arc length, it looks slightly complicated, but it ends up being more simplified. So sorry, I'm texting Julia right now to get her back in. So the arc length formula, you can write it as an S for some reason. It's the same type of thing where you write A and B or alpha and beta. That's really what those terms stand for. And the formula is radical r squared plus dr over d theta squared with respect to d theta. And that's what you're doing. That's the formula for arc length. Again, write it somewhere, highlight it, make sure you know it. And I know the integral that we just did kind of like was a little complicated, but for some reason, the integrals with these types of problems end up being a little bit like more simplified. So that's why I like them. Yeah, so just know this formula when you're dealing with like length or arc length. So what do we need to know? We need to know r, we need to know r squared, we need to know dr over d theta, and we need to know dr over d theta squared before we start solving and integrating, of course. And luckily, for these types of problems, it will always give you like your values to plug in. So that's another reason why I like arc length. You don't have to do anything with the graph. You don't have to look at it. You just know that for this problem, based on what you're given here, the lower one is 0, the upper one is pi. Easy as that. No extra work. So what's r? R is -4 sine of theta. Easy. What's r squared? Just square it. 16 sine squared of theta, right? What's dr over d theta? Just take the derivative of this. You end up getting -4 cosine of theta. And what's dr over d theta squared? It's simply 16 cosine squared of theta. Not too bad so far. And this is number 12. Sorry, I just like to follow along with my work, of course. So when we're now going to start plugging things into this formula, let's just plug in what we've just figured out. So it's of course the integral from 0 to pi. R squared is 16 sine squared of theta, and dr over d theta squared is over here is 16 cosine squared of theta d theta. And I don't know if you guys remember the identity. So what I'm going to do first, 16 inside a radical, I know that can be simplified because I know the square root of 16 is 4. So I'm going to move the 16. Oh, maybe this is easier. I'm going to factor out a 16 from here, from these two terms, right? And then what I'm going to do is, or what you can do with radicals is you can kind of like split them apart. So now I'm going to write this as the square root of 16 times sine squared of theta plus cosine squared of theta, which is just equal to 4. But I do have a question. Does this identity look familiar to you guys at all, or like no clue? No clue.
Very vaguely, but I don't remember like what it was for.
Nat, what were we gonna say?
Isn't there one that equals to 1, but wasn't it like a minus sign?
Yeah, no, yes, that's exactly what it is. This is the one that's equal to 1. The identity is simply sine squared of theta plus cosine squared of theta is equal to 1. There's no minus, it's plus. That's the identity. So notice how at this point it's an identity. This is like the most common trigonometric identity ever, so you need to know this right away. And most of these problems will end up giving you a 1 some way or another. And now all we're left with is a 1, because we can just rewrite that as 1. Notice how that just like eliminated all of our problems because all the trigonometry disappeared. So that's why I like the arc length ones a little bit more. So now all we're left with, and I'll start from the top because there's more space, is the integral from 0 to pi of just 4 d theta, because the square root of 1 is just 1 and you're left with nothing. This is very easy because the integral of 4 is just 4 theta. You're looking at it from 0 to pi. And if I give myself more room to write this, it's very easy to just plug in these bounds because it's just plugging in the upper one minus the lower one. So 4 pi minus 4, 0. The answer is 4 pi. And that one was not as bad as that other previous one that we just did. So this is definitely one to memorize, I would say. So did that one make sense?
That one made so much more sense than the last one.
Yeah, I figured. And some of them are going to require like a little more manipulation, but the point is that they usually have like something along this line so that you can just get rid of some sines and cosines, which makes your life easier, in my opinion. But yeah, so let's do one more type of problem, and it's called the surface area revolution. If I had to predict like the problem sets, I would say focus on like the derivatives that we did before. Area, there's going to be a few of those, and then there's probably going to be a few arc length because we did do a lot of those. There's only going to be one of surface area revolution, and there was another type of problem at the beginning that I don't have time to do, but like that one is like very, very, very obscure. It's actually less common than like the surface area revolution, which is the last problem I'm showing. That is for these problems over here. It's just asking you to kind of plug things in. It's the same arc length formula, but it's just asking you to set it up. It's not actually asking you to solve it. So just set it up with the formula we did with the r squared, the dr over d theta. You know what I'm talking about. So that's these two problems. That's like an easy one to do because you don't even have to integrate. You're just writing numbers. So get that one right. But the last one is the surface area of revolution, which is area of the surface. And it's again not impossible, but it does require you to know some identities, of course, and manipulation. I would say it's easier than the area, but harder than the one that we just did. But hopefully you guys can get it right. There are two formulas for surface area of revolution. And those two formulas are, wait, I lost my paper with the work I did. Okay, I got it. So the two formulas for surface area of revolution depend on what you're revolving it around. So in terms of polar like lingo, we have a polar axis, which is like your x-axis. So I'll write like an x here. And then you have your y-axis, which they just call theta is equal to pi over 2. So either you have your x-axis, which is really your polar axis, or your y-axis, which is really, they call it the line theta is equal to pi over 2. Don't ask me why, but that's what they call it. So when you're revolving it around the polar axis, like this way, there's a specific formula. And then when you revolve it around the y-axis or the line pi is equal to theta, the line theta is equal to pi over 2. So when you're revolving it like this way, it's another formula. So make sure to write these formulas down because I'm going to write them nice and neat right now. So let me just kind of copy like the image from Miss Q's notes, but at least get the background. So the polar axis one is S is equal to 2 pi, again, the A and the B. You write a Y here, and then it's the same thing as what we did before. R squared plus dr over d theta squared plus, with respect to d theta. When it's the line theta is equal to pi over 2, we have another 2 pi. This time, as you guys can probably guess, it's an x, and it's the same rest of the formula. R squared plus dr over d theta with respect to d theta. And those are the two formulas we're going to be dealing with. Obviously, it's asking for the polar axis one this time, so we're going to be looking at this one over here, and then we're going to integrate. So does it make sense so far?
Yeah, can you give me a second to copy?
Yes. Just let me know when you're done. But yes, that's basically what we're going to be doing. And notice how there's a y here, and we're only looking at d theta. So this is when it's again important to know the y is equal to r sine of theta, and that's going to be like where we first start things out. Because I kind of like to write, the givens or like the little variables inside, figure out what those are, and then just plug them straight in before I start doing everything else. Nat, did you finish it? Okay. So let me erase this bottom one because we're not dealing with that. And then let's do our little givens. So let's do y first. What is that? Y is equal to r sine of theta. R is 6 cosine of theta. So y is equal to 6 cosine of theta times sine of theta. So 6 sine of theta cosine of theta. All right. And let's do the rest. So we're missing r squared, we're missing dr over d theta, and then we're missing dr over d theta squared. What's r squared? R squared is simply 36 cosine squared of theta. What's dr over d theta? That ends up becoming -6 sine of theta, and that squared is 36 sine squared of theta. So notice how it's the same types of variables, so it's not too bad. So let's plug it in. This is sine of 2, s is equal to 2 pi. Just like the previous problem, for the bounds, you just plug in the numbers it gives you. So for this particular problem, it's from 0 to pi over 2. Y we just got is 6 sine of theta cosine of theta. And the rest of these numbers inside, we already figured out. So it's 36 cosine squared of theta plus 36 sine squared of theta d theta. To avoid like the manipulation we did before, I think it goes without saying that this sine squared of theta plus cosine squared of theta will simplify. It'll end up being, well, here, I'll just do it really quickly. It'll end up being radical 6 times the cosine squared plus sine squared. I'm sorry, radical 36 times that. This is 6 times radical 1, which is just equal to 6. So instead of doing more manipulation, I'm just going to write the 6 here on the front, of course. But to avoid rewriting that radical, you guys just know it's 6. So at this point, when you guys are integrating, it's just always important to like remove all those numbers inside the integral to the outside because you kind of want to avoid them. And for this particular problem, when you remove them to the front, you end up getting 2 times 6 times 6 because there were 2 6's inside. The integral from 0 to pi over 2. And all we have left to integrate is sine of theta times cosine of theta. Now, I didn't know how to integrate this like off memory, and I wouldn't expect you guys to know how to do this without having some type of like trigonometric knowledge. Now, I had a vague sensation that there was an identity that did have sine of theta times cosine of theta together. And when I looked it up on the internet, I was right. And that's why it's kind of important to know, like, not have them memorized, but at least kind of know what you're talking about. And I don't think that you're ever going to have to get one where you have to know this identity, because it's kind of not one of the more popular ones. But just to tell you guys what it is, the identity says that sine of 2 theta is equal to 2 times sine of theta cosine of theta. And with some manipulation, you get that 1/2 sine of 2 theta is equal to sine of theta times cosine of theta, which is exactly what we have there. Again, I wouldn't expect you guys to like know like the formulas as much as I do. I didn't even have that memorized, but I just knew somewhere in my mind that there was something that had this identity. There's like no other way to integrate this without, you know, getting rid of the fact that there's a sine and a cosine there. And when we do this, now all we're left with is a sine. So notice how I made things like 10 times easier. So at this point, I'm just going to rewrite this again. I'll simplify this here. 2 times 6 is 12 times another 6 is isn't that 6 times 12 is 72?
Yeah.
So
Wait. I have a question real quick.
yes.
So the last blue step that had 2 pi in the front, where did the pi go?
Oh my god, you're right. I'm so sorry. It's right here. I completely missed that.
Oh, okay.
Thank you. Yes, the pi is essentially there. We didn't do anything with it. So it's 72 pi. Yes, there's a pi. And I'm gonna rewrite. Oh, did someone have a question?
This is like a separate question, but like, you know how like sine squared of pi is like sine of pi times sine of pi?
Yes.
What is sine, like what is something of 2 theta? Not pi.
I know what you're talking about. It means that you're doubling the angle. So it like it just means that like whatever angle you're plugging in, like let's say that it's pi or pi over 2, you're just multiplying it by 2. That's all you're doing.
Okay, thank you.
So let me just erase what I did over here. But basically what I'm gonna do is, instead of writing this, I'm gonna rewrite this new little form that we came up with. So 1/2 sine of 2 theta. Again, it's an identity. I don't think we're gonna get an identity like this because we've never done one like this in class. But yes. In order to integrate this, remember we're missing a 2 because you need to have like the derivative of the inside. We're missing a 2 here, but remember when we add a 2, we have to divide by 2 here. So now at this point, we're left with 36 pi. There's a 1/2 here, so I'm just gonna move it to the front. 0 to pi over 2. And we're almost ready to integrate. I just wanted to clean some things up before I actually integrated. So let me erase everything at the top so we can integrate nicely, and then we're almost done with the review. So at least there's some like more knowledge than before. All right, so now when we integrate this, the first thing I'm gonna do is just simplify this so it ends up becoming 18 pi, right? Let me not write the integral again. The integral of sine of 2 theta is negative cosine of 2 theta. Because the integral of sine is negative cosine. And then it's from 0 to pi over 2. All we have to do now is just plug it in. So I'm going to move this negative to just to the front so it's easier to do it. So it's negative 18 pi now. And then we're going to plug in. So cosine of 2 times pi over 2 minus cosine of 2 times 0. The upper minus the lower. You end up getting 18 pi times cosine of pi minus cosine of 0. And then that's just knowing your unit circle at that point. So cosine of pi is negative 1. Cosine of 0 is 1. So when you plug this in, again, I feel like this one was like a little bit easier than the other one that we did, but negative 18 pi, like I said, that's negative 1. This is just a regular 1. you have negative 18 pi times negative 2, which is just positive 36 pi, and that's your answer. Like I was saying before, I just got ahead of myself. I feel like it was slightly easier, or like a little like more easier than that previous area one that we did. That was just very convoluted, but it was more challenging than the previous one we did, because that other one just worked out very nicely. We still have to deal with like trigonometry in this problem. But did that make sense for the most part?
Yes.
Okay, good. Yeah, so that's pretty much this with like that with the review. There are more types of each problem within the review she gave us, but I just did one of each so you guys would get at least like a basic understanding. So I really hope that helped. And I'm gonna stop recording now.